Fantastic. And then I'll be able to upload that.
Yeah, okay, sure. I can do that.
That just helps me a bit.
Yeah, of course.
Let's do this. Let's do this. Adele. On the Richter scale, the magnitude R of an earthquake of intensity I is given by this formula, where I naught is a reference intensity used for comparisons. Find R for an earthquake that is 4.3 million times more intense than the reference intensity. So where would you sub in 4.3 million times more intense than the reference intensity? What does that even mean? What's the question? Find R for an earthquake. Does anyone even understand this?
Not the words.
Not the words. True. So then let's forget the word for a second. It just says this is R, and it says I over I naught. I is the earthquake intensity I, and I naught is a reference intensity used for comparison. Whatever that means. Find R for an earthquake that is 4.3 million times more intense than the reference intensity. So if you want to find R, obviously what must kind of go? You know that I and I naught must somehow disappear, but you know that I naught is a reference intensity used for comparisons. So therefore I must be 4.3 million times I naught, the bottom one. Yeah. So it looks like this. R equals log subbase 10, 4.3 mil times 10 to the 6 I naught over I naught. And then what will happen with your I naughts? We'll just cancel out, and then you just subbed in 4.3 million. Make sense? That's how you read these. I of I naught is a reference intensity of, that's it. Question? Any questions? Where are you stuck on?
On your weight one.
By I naught?
Yes.
It is 4.3 million times more intense than the reference intensity. What do you mean?
I know. If you're just going to cancel it out.
What's the point of it? It's only used for comparison. So you can go, hey, look, I naught was like, what's the point of it? See, like when you get to the Richter scale, say it again.
If you have a second, you can compare it to.
Yes, correct. So you could be like, hey, this one is, I think that's what the next one's saying. How much more intense is this than the reference intensity? So like, whoa, this, like the fact that it measured 8.5, this earthquake, whoa, that is this much more intense than what it should have been. And this is actually true, obviously. This is what they use for measuring earthquakes, the Richter scale. But anyways, any questions there? Plug it into your calculator. If you're going to use, because it's a subbase 10, you're allowed to use log on your calculator. If you didn't, then you have to do ln of the top over ln of the bottom.
I understand like the
times.
So how did you make it so that the?
Can I pause for 1 second just to answer maybe his question again? Hopefully this will answer your question. Let's just say you didn't even sub in I naught for some reason. You just put in 4.3. But I said when someone was asking just before, I went, fine. Oh, you said, yeah, I get it, but except the words or whatever. I went, oh, you're trying to find R. You're trying to find R. I and I naught must disappear. The only number you have is 4.3 million. You're going to be like, oh, if I is 4.3 million, the hell's I naught? Then you hopefully will go, right, I naught must be the reference in 4.3 times in the reference intensity. 4.3 million times reference intensity I naught. Okay, right, I naught goes on the top and then sweet, just cancels out. I actually have no letters here. I can actually work this out. But go, your question now.
But how does I naught go to the top? I don't understand that.
I is the intensity. On the Richter scale, the magnitude of R of an earthquake of intensity I, find R, that is 4.3 million times more intense than the reference intensity. So what was I?
The intensity. Right?
Yeah, which is 4.3 million.
Well,
It's not 4.3 million because it's 4.3 million what? Cows? $4.3 million, 4.3 million kilograms, 4.3 million times the reference quantity, amount, unit, whatever it's meant to be. Does that make more sense? What do we think? Boys in the back. You're going to get in your exam. You're going to be like, I wish I had understood it back then. Yep.
So could I like, so is I not kind of like unit of measurement? If you think about it.
It kind of is. That's why it's there. It's saying it's used for comparisons. It is a unit of measurement. If you would compare it by saying, yeah, I mean, I think B would kind of explain it, but it's like saying, hey, it's triple the amount, quadruple the amount of our reference quantity. Whatever you want that to be. An earthquake measured 8.5 on the Richter scale. So now that becomes 8.5. How many times more intense is this than the reference intensity? This one. Earthquake measured 8.5 on the Richter scale. How many times more intense is this than the reference intensity? We all know how to solve a log. What are you going to do as your next step? ln? ln top over ln bottom? That would make sense. Then what are you going to do? What are you going to do now? Move the ln 10 over. What are you going to do now? So imagine that's just log I over I naught. What are you going to do to get rid of the ln? E it. And then that should be it, because once you've multiplied by I naught, that will be how many times more intense it is than the reference intensity. So can we please all get this answer out? I'm going to check as well. So go E to the power of ln 10 times 8.5. Question 8A and B. Question 8A. Should have hopefully been that. You guys will confirm. Was it 6.6? And this one should be 316 million. This one's 316 million. Someone's going to confirm. 316 million? Now, how many times more intense is this than the reference intensity? The reference intensity is I naught. So as you can see, when you multiply it over, I is 316 million, right? I think it said. But times 10 to the 6 times I naught. It is huge compared to the reference quantity. So a Richter scale of 8.5, you've got a disaster compared to, let's say, the first one there. The word didn't matter. Maybe understanding the reference quantity is a little bit of a understanding thing, but as you can see, the math was quite simple. I didn't do anything. As long as you can get over the line with the words. Sounds good? Should we do number 9 as well now? Anyone have any questions? The math? So let's see if we can apply that to number 9. Number 9. Rather than the Richter scale, you've got a decibel scale, which measures loudness now. The loudness L of a sound of intensity S. So again, the intensity this time is S. Loudness L. S naught is a reference intensity used for comparisons. A sound that causes pain in humans is about 10 to the 14 times more intense than S naught. So one more time, a sound that causes pain in humans is about 10 to the 14 times more intense than S naught. So what does S equal to? What does S equal to? What does that sound equal to? Close. Correct. Is about 10 to the 14 times, because what's 10 to the 14? What's 10 to the 14? Sorry? I didn't hear it. Infinity? Yeah. Is that what you said? It's a very large number. But again, because you don't have units, what 10 to the 14 is a very large number. What is that number? Like is it decibels? Is it centimeters? Is it meters? But you understanding what I'm asking, what I'm saying to you? I'm saying if you're just going to sub in like log 5, let's say the number log 5. 5 what?
Right.
But 5 what, right? Like 5 what? Like what are you actually logging? 5 centimeters, 5 meters, $5, 5 animals, 5 atoms, 5 what? So there's going to be some sort of unit with this, and that's what this is trying to do. There's always going to be a reference quantity. That's how it works for logs. So there is no such thing as just a number there. I know we have done just numbers. Technically, it doesn't exist in the real world like that. That's why you've got these reference quantities. So when you're doing 10 to the 14, it says times more intense than S naught. So therefore, S would equal to 10 to the 14 times S naught. And then obviously the answer for L should be very easy now. 10 log subbase of 10, 10 to the 14 times S naught over S naught. Go and get that answer out this time. %99% of students can't use their calculators for these great topics. They accept the math because the math doesn't look hard. They don't know what to put in their calculator properly. All right. 10. Can you guys see that number? Surely you know it. It's 10 to the 14. 10 to the 14. 10 log subbase 10, 10 to the 14. What should I get from the top of my head? Maybe 140. Right? 140. So that's the loudness. That's it. If we get past that loudness level of 140, you're pretty much, your ears are going to hurt a lot. And that, how many times more intense is the sound of a heated argument? So if you get angry and you start talking loud, which is about 67 decibels, then the sound of a quiet room, which is about 31 decibels. Okay, what do you guys think you're going to do there? How many times more intense is the sound of a heated argument, which is 67 decibels, than the sound of a quiet room, which is about 31 decibels? Sound. I would do it like that, do that, do that, so that. Checking my work. Fine. B. Right there. Do that, compare. Hopefully, math is right. Okay. So, S naught is your reference intensity. That's how you're going to work out how many times more bigger it is, I guess. So, if you've got how many times more intense is the sound of a heated argument, which is about 67 decibels, you're going to make, that's your loudness, 67. So 67 equals 10 log subbase 10 S over S naught. Can we do the same thing for 31? Can you please go and work out, and let's just to make it easier, they call this S2 and call this S1. S naught does not change because that's your reference comparison. You're going to compare it to that number. So can we please work out what S1 and S2 is? Please try to find S1 and S2. You can start writing. So first step in will be divide by 10. Then change your logs to LNs and then bring them over. You're out with that ratio? So 67 divided by 10. Change your base of ln of the S2 of S0 over ln10. Eventually, you're going to multiply ln10 over. Then One by one. For now, divide your tens over. Try to find what S2 over S0 and S1 over S0 is. Should just be dividing. And where are we looking for eventually? 3,980 times. All right. Hopefully, these have been your steps. 67. Lauren, have I confused you anywhere, by the way?
I'm doing okay so far.
Okay, 67 over 10 is 6.7, or whatever that becomes, ln of S2 over S0 over ln of 10. Bring the ln 10 over. And then we get whatever that becomes. And then you guys should have something like this. S2 over S0. Do you guys have it as a decimal or an exact form? Do we have it at all yet? Stuck? Where are you stuck? Let's go to another page. So we're here. We're at 67 equals 10 log subbase 10. And then this is just a variable. What's step one?
67.
Okay, we're here. What's step two?
Change the log.
Change of base. It's actually called change of base. S2 over S0 over ln10. What's the next step?
Bring the ln.
What's your next step? You can't have a non-ln with an ln like that. So what are you going to do with the 6.7? One of your log laws, try to remember. What are you allowed to do with the numbers in front of your logs?
Change it to the
Done. And then what are you going to do with the ln's? Now that you have ln equals ln, ln equals ln, you can em or you can just get rid of your ln's. So you've got 10 to the 6.7 equals S2 over S0. Got it? Now that we kind of know that, I think we can cheat for the next one and say, what was the other number? 31, thanks. So I think we can say that it should be 10 to the power of 3.1 is equal to S1 over S0. If I'm not wrong. 31 there, you divide it. I think so. Okay. Any questions at this stage? Question says, how many times more intense is the sound of a heated argument compared to a quiet room? So how many times is this larger pretty much than this? How would you work that out? Yep, divide them. Which one goes on the top? Which one goes on the bottom? Big one goes on top. How many times this one? Yeah. Wrong? Small one on top. Right? How many times is 4 more than 2? Yeah. Oh, yeah. Why does my head say the other way?
Wait, does 4 go in 2 or does 2 go in 4?
Wait. How many times is 4 bigger than 2? Times is 4 bigger than 2. 2 times. No. That's a basic math. Why was my head saying to do 2 times 2 gives you 4? But you're saying, yeah, so therefore 4 divided by 2. It's a larger number. Yeah, fine. Yeah, fair enough. I don't know where my head was at. S2, let me read the question again. How many times more intense is the sound of a heated argument? No, it's right for that one. I wrote it wrong. How many times more intense is the sound of a heated argument than the sound of a quiet room? How many more times? Yeah, English. How many times more intense is, how many times more bigger is 4 than 2? 4 is half as big as 2. Yeah. Slow it down. Slow it down. Let's make sure that I'm right because I don't want to, because I could be wrong. Let's say it again. How many times more bigger, unless I'm completely wrong, I'm losing my mind. How many times more bigger is 4 than 2? How many times bigger is 4 than 2? Wait. How many times bigger is 4 than 2? You would say 4 is half as big as 2. No, 4 is double the size of 2.
2 is half.
2 is half as big as 4.
It's not a half because isn't half is 4 too, so it's the same either way. So if you do like 65, it might be different.
Which is
But it's still bigger or smaller.
It doesn't make a difference, right? Maybe it's just the way I'm trying to. It's the context. Maybe not. Who knows? Let's find out the answer. Go. If I had to make a final decision, one more time. Let me read it one more time. I don't disagree with you guys. Don't worry. So I don't disagree. It's just my head. How many times more intense is the sound of a heated argument than the sound of a quiet room? So the heated argument would obviously be louder, so it'd be more intense. So therefore, you're going to say it's just larger than this one. So then the reference quantity. We'll find out. Go. Do 10.67 over 10.31. And we'll see if we get the right answer. 10 to the power of 6.7 over 10 to the power of 3.1. 3,981, which I think was the answer. So I'm just losing my mind. Don't worry. I'm just being stupid. Leave it. Done. Do we get it? As long as you don't make any silly mistakes like me. Are you good? All right. All right. Any other questions from this booklet, from the exams that you guys were meant to do, obviously as part of your homework, or any questions from school? Right now is the best time. So I'll stop that there.